All right. Thank you for tuning into the Teach Me DeFi podcast. Today is a good one, a lovely one, because we'll be diving into some topics like data availability, modularity of blockchains, and all of that. So quite technical, but we will try to simplify these topics. From listening to other podcasts that my guest has been on, he's quite good at that. So I'm excited for this. We got Prabal here today, co-founder of Avail. Hey, mate, how are you?
I'm good. I'm good. Thanks for having me on this podcast.
Lovely. We're excited to have you. And I mean, this is a really hot topic. It's like I guess you could say one of the narratives that are mostly discussed at the moment in the market, but it's also a bit like elusive and quite technical to wrap your head around, especially if you're like a non-technical person. So I thought this could be a really interesting chat to have to kind of get a better understanding of this topic and why it's important for the crypto landscape. But like before we get into all of that, I would just be curious about the story behind the person. You've been in the industry now for a while. Just tell us a bit about your background. I mean, what brought you then to Polygon as well, and what inspired you to start Avail and all of that?
Yeah, cryptography is what I was interested in, and during my education, also I was pulled into that field, and over time, from cryptography, I slowly moved into cryptology and security, and then came into the world of blockchains. This was mainly when I started my PhD program in 2016, when I first started looking into, in a more formal manner, the blockchains of the world at that point in time. And immediately, Bitcoin and Ethereum, they were at the forefront of this technology, and it grabbed my attention, it captured my imagination, and so I started spending more and more time into it. Apart from that, also there were other projects like the Linux Foundation, Hyperledger project, and Hyperledger Fabric, and so on. Those were also very interesting to me, and though they were the ones with whom I started my journey. Um, After 4 years of research, I realized that although I'm able to, come up with algorithms, come up with protocols which can be helpful in the data retrievability, in the fairness of data exchange, in that kind of space, but I felt that the impact was missing. I felt that the users could not directly use the protocols that I was helping develop, and so on. And that's why I was looking for an opportunity where I can make more impact. And that's where I saw an opening in Polygon. It was Matic at that point in time. So I joined them, and I started as a researcher in Polygon. At that point in time, they were already a production grade chain, one of the only scaling platforms that was available for Ethereum. And they already were trying to solve the Plasma challenge. So they were trying a scaling solution named as Plasma. It's pretty hot right now again. But at that point in time already, they were trying to solve that. But they quickly realized that data availability is one of the core problems that need to be solved before the scaling problem can be completely be addressed. And that's where they pivoted to a more POS chain, and data availability was one of the first problems I started working on from within Polygon. And yeah, in the 3 years, almost 3 years that I was there, I led the research team at Polygon. At one point in time, I contributed to various different protocols within the Polygon umbrella. Mainly, my focus had always been data availability and Avail. But other than that, also the POS chains, try to help the ZK teams, and so on and so forth. And then after that, in 2023 March, we spun Avail out of Polygon along with my fellow co-founder Anurag. Anurag was, of course, the co-founder of Polygon, and that we wanted to create a credibly neutral DA layer because we understood that from within the Polygon umbrella, it's very hard to be unopinionated, and we wanted to be that. So that's why we spun it out, and that has been my journey since.
Super exciting. So you kind of started out in research and then decided to put some of those things in action yourself, is it?
Yeah, I mean, the research part was pretty good, but at the same time, I was missing the applied part of that. During the research, also, I wanted to do more hands-on work, and that's why I had gone to a few internships. And the industry which was working on solutions that were being used by the users always fascinated me, and that's why I wanted to, shift into something more hands-on where I can contribute more, get into the bottom of it, uh, like really build and contribute solutions which can be tested on production by hundreds and thousands of users and
Mm.
create the new forefront which can scale this technology.
Mm. And I guess Polygon was a logical choice there in terms of testing things at scale, because it's one of those popular and adopted layer twos on Ethereum.
Yeah, I mean, they were always like trying to build new things in order to scale Ethereum. Um, from early on itself, as I was mentioning, like the Polygon POS chain was one of the only scaling solutions for a pretty long period of time. Rollups, they had already started investigating about rollups, about the ZK rollups. They were convinced that ZK rollups can be the one thing that can scale and create the best L2 experience and so on. So they heavily invested in ZK, and we can see those efforts bearing fruit right now, where there are 2 3 teams even within Polygon building ZK rollups. Some of them are in production. Even a few days back, the Type 1 ZK EVM was launched, and so I mean then there is Polygon Maiden, which is more about adding more features into rather than EVM. So yeah, I mean they were always trying to do new things in order to solve the scaling challenge.
Mm. And you mentioned the spin-off. So I also remember from another interview you did, I think on a ZK Knowledge podcast, if I said it correctly, and that the spin-off, like what motivated it instead of continuing to develop it in-house at Polygon?
No, if you think of the L2 landscape right now, you will see that there are 4 or 5 major players out there, right? There is Optimism, Arbitrum on the optimistic side. There is ZK Sync, Starkware, and Polygon on the ZK side, right? And when we were building from within Polygon, we would lose, 4 out of the 5 major players because they would not want to build their product on a competing solution, which was
Mm,
secured by a competing token, for example. And
mm,
that's why it was a logical step for us to, you know, we wanted to be neutral because a DA layer can only be very powerful with a sharing of security across the L2s which use it, only if many different L2s built by different players are using that. And unless there is a solution which is used by everyone and anyone, you cannot build a pretty nice and robust solution, right? So that's why it was a logical step for us to spin it out. And within Polygon as well, they had been focusing on many different products, but out of them, like they wanted to focus on the scaling Ethereum through the L2 space.
mm.
And Avail was this DA which didn't really fit well into the category that they were pioneering, and that's why it also made sense for them to you know allow us to spin off.
Right, yeah, that makes sense. So sort of like credible neutrality for the A layer instead of it, for example, accruing value to a directly competing token of these layer twos. So you already mentioned now DA and data availability. I would love if we manage today to kind of break that down a bit, to explain it as much as we can in a bit of a non-technical way. Can you tell us first, perhaps, about the design components of a blockchain? So we start there and then go deeper. I had a look at your docs. I think there you broke this down into like data availability and then execution and verification. Is there any way to start off there and then dive deeper into like what the problem is and why Avail is needed?
Yeah, of course. So I think let's start with a typical blockchain. Right? In a typical blockchain, what happens is that the users, they send transactions. The transactions get broadcasted across the network. The validators or the miners of the network, they take those set of transactions, include it, and forge a block. And that's how the blockchain progresses. That's the typical flow of a blockchain. Now, Bitcoin, Ethereum, and such, there are differences in their design choices. Not going into the nitty-gritty details, let me just take Ethereum as the de facto standard for explanation. And then if you have specific queries, we can go into Bitcoin. But in Ethereum, these validators, they actually take this set of transactions, execute them, and then find the final result, which they publish as part of the block. So in a more, if you had to break it down a bit more, every transaction actually changes the state of the blockchain. So, for example, the state of the blockchain contains, let's say, all the account balances of all the users who have an account, right? And a transaction is a way of sending balance from one account to the other. Let's take that simplistic view. Of course, with Ethereum, there are many other things that can happen. But in the very core of it, let's say this is an example that we start with. In this example, the change of state, which means that my account needs to be debited and yours need to be credited, for example, these operations change the state of the blockchain. And these are the transactions which need to be signed by the sender. Now, the validators, they have executed it and put the final state or a hash thereof inside the block and propagated it. But all other validators and full nodes, they need to re-execute it. Why do they need to re-execute? Is because they need to be convinced that the result of the execution is correct. So a familiar example is, let's say you give me a math problem to solve, and you say, what is the sum of 1 plus 2 plus 3 plus 4 plus 5, let's say. And I compute the result and then I give it to you. I give you all the steps. You can go through all the steps of the math problem, see that the solution is done correctly, and then agree that the final outcome is correct. This is known as the re-execution paradigm. And most execution-focused L1s, they do it in the similar manner. Now, the problem with this approach is the fact that it is very hard to scale in a secure manner. If the amount of computation that everyone needs to do increases, the entry barrier also increases. Which means that if you are just a full node, and mind you that full nodes also need to re-execute all the transactions, not just validators. So if you want to be just a full node and participate in this blockchain, then also you need to have a beefed up machine. If every block contains a lot of these transactions, because the transactions execution take resources and you have to be up for it. This is a typical scaling problem in blockchains. And this is where the L2s come in terms of the rollups which scale the execution on these chains. Till now, does it make sense?
Yeah, it does perfectly. Yeah.
Awesome. And then what does these L2s do is that they take these transactions, they take it off chain, execute the transaction, and then provide a succinct proof of the correctness of execution. Now, the proof can be either a zero knowledge proof or a validity proof, as it should be called, or it can be a fraud proof. So either you can say that, give me a proof that you did the execution correctly, or someone give me a proof that they did the execution incorrectly. So if you show that it is a valid execution, then you give a validity proof.
Mm-hmm.
If you show that it was done incorrectly, then you give a execution fraud proof.
Mm-hmm.
And this is the two major paradigms that we see today in terms of the L2 landscape. There are, of course, other solutions out there, which I don't want to get into to complicate.
Mm-hmm. Yeah.
Now, that makes this execution scale, but you still need the data behind those executions available available on the layer 1. And that is one of the problems that needs to be scaled as well. And that's where Avail comes in. That's the data availability problem that Avail wants to, with the Avail DA part, wants to come in and solve. That is the data availability problem behind the scaling challenge that we are facing in blockchains today.
Can you explain this part again? So in terms of let's say they publish the fraud proofs, for example, to Ethereum, to the layer 1. But then you said they also need to put the data on Ethereum as well.
Yeah.
So they do these two things at the moment.
Yeah. So in optimistic settings, and this is a very it's worth understanding this problem in this lens, is suppose that I publish the execution result. I am a sequencer. I publish the result of the execution, but I do not publish the data behind the execution.
Mm-hmm.
Then everyone else in the system can neither accept, because they don't know whether it is correct or not, but can neither refute, because they will not be able to find a fault in my execution and the result thereof. To find a fault, the data needs to be available behind that execution. So for example, let's go back to the example of 1 plus 2 plus 3 plus 4 plus 5. Unless you know that these are the inputs over which I was adding things, if I give you any number, let's say I give you 100, you wouldn't be able to say that 100 is not the answer, because you don't even know all the details of the question. Of course, I'm dumbing it down a lot. But that's the level of nuance that you need in order to make the optimistic paradigm secure. So when the data is not available, optimistic rollups completely lose their security guarantees because they cease to be secure without data availability. Now in the ZK paradigm, it's a bit different, because in ZK, because of the validity proofs, there is a cryptographic proof that I computed the result correctly. However, you still need access to the individual states and such. Otherwise, you get a problem of liveness, where your accounts can be frozen and you will not be able to spend your balance and so on. So there's a different problem in ZK, but there's a different problem in optimistic, but both problems relate to data availability.
Okay, gotcha. So perhaps a bit of a stupid question, but what is the actual data then? Is it like the transactions, like this much went from A to B, for example, just simplified, or?
Yeah, so mostly the transactional data is the ones behind the rollups. There are nuances there. If we have to just say a blanket statement, I would say yes, it contains all the transactional data. But there can be more nuances on top. For example, in ZK rollups, you can avoid signatures because signatures are not needed against the transactions that you are sending. And then in some ZK rollups, they do not send the transaction data, but they only send the state delta and such. So there are different constructions in the space. A big design space is available, but roughly speaking, yes, you are correct that we need the transactional data.
Okay, and so and then Avail comes in and says, okay, you don't have to post the data to Ethereum. you can post it to our chain. Can you expand
Yeah.
on that?
Yeah. So now, if you take a look into Ethereum right now, Ethereum has this rollup centric roadmap, right, where it wants to be the settlement layer for all these rollups on top. But right now, it is not meant to handle all the data that comes from all the L2s. For
Mm.
example, almost today, like it takes around $1,300 to $1,600 per MB of data to be published on Ethereum, right? So it's
Mm.
extremely costly, and almost 90%, 70 to 90% of roll-up costs that the users give are actually the cost for data availability. Now, what Avail says is that we are trying to build a DA layer which is custom built for data availability only. Mind you that it's not that Ethereum doesn't have this in the roadmap, or that it will not be able to address this. But the point here is, because it started off as a world computer model, it started off as an execution engine, it still has a few years of development left until they can give the full danksharding.
Mm.
There are intermittent solutions which are hitting testnets this week and mainnet in March, called EIP 4844 or proto-dank sharding, which will ease a lot of pressure, but it will
Mm.
not be enough at all. And that's why what Avail says is, you take those transaction data, you send it to Avail, which is custom built for that purpose, and then Avail gives an assertion that the data behind the transactional hash that you published is actually available.
Mm.
So apart from Ethereum, like instead of Ethereum giving an assertion of data availability, Avail gives an assertion of data availability, so that executional guarantees and proofs on top can be settled on Ethereum.
Mm. And this assertion, is this also then sent to Ethereum, or does Ethereum only
Yes.
get the... okay.
So there is a vector X is what we call the bridge. So there is a zero knowledge proof based bridge from Avail to Ethereum called vector
Mm.
X. And that posts an assertion that the supermajority of validators of Avail have agreed to the fact that there is that the data behind this root of data is available on Avail. Right? So
Mm.
that's the assertion that Avail provides to Ethereum. Of course, there are other ways to get assertions. For example, in the final state, we want to say that the users should be able to run data availability sampling light clients in order to get the assertion themselves without relying on the validator set of Avail. And we are already pushing for the DAS to happen within wallets and so on, so that users don't have to worry whether the data availability is there or not. It will be automatically be sampled and verified inside the user clients.
Right. Okay. That's two things now. Let me order this in my head. So, in terms of the assertion that you sent across with that bridge, so you don't send the data anymore to Ethereum. You just basically assert. You saying, okay, the data is here on our chain and it's been validated by our validators, so to say.
Yeah.
So this is
Yes.
less costly than the other route that is currently the paradigm.
Yes, absolutely. Like it is orders of magnitude less costly.
Mm. So then I suppose this assertion is backed by the crypto economic security of Avail, is it?
Absolutely. And that's why this particular bridge and the assertion that Avail provides on Ethereum is based on the crypto economic guarantee of Avail. And as I
Right.
said, that there are other ways to do it. Probably we will cover it later.
Right. Okay. So what does it look like at the moment? Are all these layer twos sending the data to Ethereum and incurring these high costs and perhaps delays? I'm not sure. Because I also remember you mentioning there's these data availability committee solutions, which sounded a bit more centralized. Yeah, can you just give us a bit of an overview what the current situation is and what the trade-offs are, perhaps.
So right now there are many different rollup orientations, or I should say L2 orientations in production. There are instances where there is no data assertion. For example, we have seen, I think right now, I might be wrong here. So, but Manta uses external DA, but there is no data assertion that is posted on Ethereum against which the check is done, although Ethereum acts as a settlement layer. I might be wrong here, but that's the latest that I knew. There are other orientations, for example, in StarkX and in Arbitrum Nova, there is a DAC. So there is a data availability committee of, let's say, 5-7 people, and you assume that a minority of the committee is honest, and that's why the data behind the transactions are available. They are extremely centralized, which means that you will have to corrupt, a very small set of nodes in order to corrupt the entire chain. And depending on whether you're a ZK or an optimistic rollup, there are varying levels of guarantees. There are other production grade rollups, for example, the Arbitrum 1, and then there is Polygon ZK AVM, the ZK Sync. These are the production grade rollups which uses Ethereum for DA. But within them also there are differences. For example, Arbitrum and Polygon ZK AVM, they use the transactional data, whereas Starkware, the Starknet, and the ZK Sync era, I think they use they use state deltas. So they are using a different orientation of DA, as we were discussing a while back. So there are various different forms in which the data availability is ensured today. All that aside, I think if we have to not care about any of this and only talk about user level impact, then there are two things which we need to be careful about as a user. The first thing is cost, because cost is what dominates use cases. So we need to be aware of costs, but then we need to be also aware of security, because almost always these two are at odds. If you want a high security, you might want to have to pay more. And if someone is giving you extremely cheap, then there might be some compromises in security or guarantees that they give you. So that is where the nuances come in. But hopefully all of this will be abstracted in the near future, so that users can be much more confident when they interact with such systems, rather than having to understand data availability, what are modular blockchains, what's a rollup, what is a ZK proof, and so on and so forth. Hopefully, we as an industry will be able to, give the users much easier mental models to think about these constructs.
Right. And so basically, it means you guys have to you be your own standalone blockchain, right? And you have to bootstrap security yourselves, like validators, and then the crypto economic security in terms of like how much is the stake worth in that blockchain that is securing it, so someone cannot come along and get 2/3 of the power to influence the blockchain or whatever. What are you doing to kind of get there?
Yeah, so there are a few different goals that we have in that regard. The first is we want to be an extremely secure blockchain. Because we are standalone, we want to be a DA layer, and that's why it's important that we have enough crypto economic security so that users feel confident when they use an L2 which is using Avail for DA. So that's one objective. The second is decentralization. And that means that we want to not only support a wide number of validators on our chain, but also a very even distribution of stake because that is important for us. It should be extremely hard for any adversary to control 2/3 of the chain, as you were mentioning. And then there are other goals like, what do we do for interoperability? What is the kind of bridging and so on, so that the user experience looks the best for our case. So we are doing different things for different regards. The ones which I would be kind of want to say right now and emphasize upon is that our choice of using Substrate was guided by the fact that we can support a large number of validators. For example, you can see, something like Kusama has almost 1,000 validators right now, and it works fine. So we are very confident that a production grade chain can be built with a large number of validators using that SDK. And then the nominated proof of stake and the fragment election algorithm within Polkadot SDK allows us to have the stake in a more decentralized manner, so that corruption of 2/3 or even 1/3 is extremely hard. Our decentralization factors like the Nakamoto coefficient and such remain extremely high, and we are able to offer a live chain even if there are faults in terms of the network partition or nodes going down or things like that. So we have a hybrid ledger with Babe and Grandpa using the Polkadot SDK, right? So those are the kind of things that we are already doing on, that's why we have chosen the Polkadot SDK, and those are the experiments that we keep doing on our testnet. In terms of validators, we have also tested around 310 to 350 odd validators on our Goldberg testnet. We have recently reduced it to a handful, but even a few weeks back, we had around 300 validators participating actively in the validator set. There are more than 2,500 full nodes running. There are, we have plans to run thousands of light clients also. So we are trying to make sure that our decentralization is top notch, and the ability to run a full node is by almost anyone, or anyone is able to run a light client to get high degree of confidence of data availability without having to participate in consensus, without having to stake, without having to run a full node, which can be challenging as well. In terms of other crypto economic security, of course, we are going through internal tokenomics design and such, which we will release in due course of time, where we want to optimize on the amount of stake, on the actual staking ratio, the yield, so as to optimize and make sure that validators earn enough in order to have a profitable, way of running a node.
Right. You mentioned Polkadot SDK there, or it was called Substrate before. What role does the Polkadot SDK play for Avail in Avail's infrastructure? And why did you choose that framework? I read that you were thinking about either Cosmos SDK or Polkadot SDK. You went with that, and I think you also modified it a bit to fit your purposes, customize it a bit. Can you just expand on why you chose this and what this enables Avail?
Yeah, so Avail at its core in the infrastructure is a two-layered architecture. So there is a blockchain layer and then there is a light client layer. On the blockchain layer is the one which produces the blocks, and there we use the Substrate framework to create that blockchain. Of course, Substrate is meant to create standalone chains or parachains for the execution world, but we wanted to make it for a data availability focused chain. So there were a few or a handful of changes that we had to make, and Substrate allowed us to make those changes, and that's why it was a top choice for us. For example, we changed the header structure, the header construction. We introduced the KZG polynomial commitments and erasure coding. We introduced RPC methods, all the tooling with minimal amount of changes, and so on and so forth. Because it was such a modular SDK where things can be changed and plug and play. It helped us to make sure that we are able to achieve the dream of building a DA focused blockchain by using
Mm,
a Polkadot SDK. Now, apart from that, there is this light client which provides an overlay peer-to-peer network on top of the blockchain network. And
mm,
these light clients do what is called as data availability sampling. And
mm,
we can go get more deep into what is data availability sampling and what the security that it provides. But that client we had to write from scratch on Rust. And because from the very beginning we were using Rust as our framework, um, again, the Polkadot SDK or substrate fit really well into that notion because it was in Rust. We saw the high performance that it can deliver. Our code where initially the POCs were in Rust, so all of that make perfect sense for us.
mm. Okay, that's really interesting to hear. Um, and I'll get to the light clients as well because I think that's an interesting topic. But uh, perhaps also the question: why not then become connected to the Polkadot ecosystem? Right, when you're using the framework, the open source framework, you'd have the crypto economic security of Polkadot, like in the billions of dollars already. You don't have to bootstrap that yourself. Yeah, and you also get like interoperability to all the other chains connected to Polkadot. Is that something you have thought about, you went through, or are thinking about? Just tell us a bit about this.
Yeah, no, that's a fair point, and we have of course thought about that. There are two main ways to answer this. The first is purely technically, because we had made a huge amount of changes in the header structure, because the low amount of execution that we want to perform on chain, we don't want to support a lot of different palettes. We want to keep the execution framework to the minimum. That's why
Mm,
the parachain, even if we had connected, it would probably have been incompatible. Like, I
mm,
think very early on, we were having this discussion with Parity, and I think we both mutually agreed that it was not possible to, be as a parachain. Although we were not
mm,
considering to become one, but technical feasibility is something that we were discussing at that point, and it was immediately clear that it was not feasible. I think later they made some changes which can make it generic enough to be able to plug in, but I'm not sure. I haven't looked into it for a pretty long amount of time. The second part, which is probably more important, is that we wanted to be a sovereign chain
mhm,
which has bootstrapped its own security. Because, as I mentioned before, sovereignty, becoming an independent chain which wants to be credibly neutral across all ecosystems, are
mm,
extremely important to us. Like, for example, today, not only Ethereum centric rollups use us, but also, some parachains who are looking to become rollups also use us. There are other, discussions about chains which are already a parachain having something add on which uses Avail as well. And this is not only that, we are also having discussions with Cosmos based chains and so on. So we wanted to be this neutral layer which
mm,
all of the different ecosystem players feel safe to latch onto
mm,
and use, and not
mm,
become like, too engrossed in any one of these ecosystems so as
mm,
to, ward off the rest. So that's why it is important as an ecosystem front, but also on the crypto economics front. Because if you think about it, like, we need to be neutral not only in the ecosystem or the technological front, but also in the crypto economic front, so as to be the shared security layer for all the roll ups sitting on top.
mm. Right. Yeah, I think that makes sense. In terms of tooling, though, I assume, I mean, you using the Polkadot SDK probably opens up a lot of options and optionality and opportunities to not have to reinvent things, obviously, and to use what's there. Do you use tooling of the Polkadot ecosystem? If so, what do you use?
Yeah, absolutely. I think we do use a lot of tooling because, and that is one of the major reasons why we, didn't build our blockchain from scratch. We used an SDK because the tooling is very important. We don't want to reinvent a wallet. We don't want to reinvent indexers, explorers, RPC providers, all the entire suite of it, right? So even today, I think we use um, subquery for indexing. We use someone like Talisman, subquery, subwallet, and such for wallets. We use the Polkadot Explorer, Subscan
Mm,
for explorers, and yeah, I mean pretty much all the toolings like the Polkadot JS API, the GSRPC for Go clients, the SubXT for Rust backend, like overall the entire tooling
yeah.
suite, whichever is relevant for us, even including validator dashboards, including other pieces of software like validator management systems and node operators solutions and such.
Mm,
We are either using them or trying to use them.
right. Right. Yeah, I suppose that makes sense. If you have tooling already available, you can focus on sort of the core components of your product instead of having to create explorers and things like that.
Yeah, absolutely, and that is one of the reasons why we would anyone would want to use an SDK rather than as I said, like starting something from scratch. Not only can you build on top of giants which already have stress tested the code, using it in production and such. You also get the community help. Like whenever we face issues on the chain, we
Mm,
know there are other players who we can reach out to. They have been so helpful in terms of crisis and so on. And that's why it's important to be part of a code base which is heavily used, which is heavily
mm,
looked into, because security vulnerabilities and such, we also rely on the SDK to be able to find those problems and such. So yeah.
mm. Yeah, yeah. You mentioned palettes, which are sort of, I suppose, for someone who doesn't know, I guess it's sort of like plug and play modules that give your blockchain sort of capabilities. So you don't have to code them up yourself and you can just like choose them. Um, Simplified. Can you talk about maybe what you're using there, for example? I mean, for example, um, you got the governance palette, for example. Is that something like, how do you think about community and governance? Is that something you would think about implementing to have like on-chain governance and voting, which I think is pretty advanced in the whole crypto landscape, the way that the Polkadot SDK has it, or any other avenues worth mentioning?
No, absolutely. I think governance is one of the strongest suits of the Polkadot ecosystem. And that's why we definitely want to use that. At the same time, governance is a double-edged sword, right? Which needs a mature community in order to
Yeah.
be able to handle that responsibly. So the way we are progressing, and which I think is the way most communities progress, is through iterative governance, in the sense that we start off with pretty centralized, I wouldn't say centralized, but through a technical committee of sorts, a committee based governance, that is, and
Mm-hmm.
then slowly open it up for the community, so as to give them more and more powers. For example, I think Polkadot also recently, only recently was able to scrap their committees and move
Mm, yeah.
towards fully decentralized governance. And that is the kind of way we want to also go ahead. The good thing is that the tooling exists, the community maturity exists. There is a clear way in which this works out, and we would be benefiting from that. But at the same time, concretely talking, like on day zero of the mainnet, we will not have the entire governance palettes enabled. And
Yeah.
people like our community already knows that, because we started with a big amount of like control to the governance. and then we had to slowly keep like reducing it step by step so as to reach a
Mm,
community-based governance, which we found as the right fit. So we
mm,
also took iterations in order to, limit the powers because they were being abused, and we realized that given the stage that we are at, we need a more greater control in the beginning, which we can slowly, as things mature, we can slowly offload it to the entire community.
right, right. Yeah. So you kind of the roadmap is there, but you're kind of pragmatic in how you go about it first to ensure the maturity is there for any kind of system you put in place. Um, I'm just wondering, perhaps a little off topic. In terms of crypto today, what do you love most and hate most about it as it stands today?
I think I genuinely love the excitement, the awesome amount of work. In fact, the awesome amount of cutting edge research and development that is happening in this space is just breathtaking. I mean, there are only a few other fields in this entire planet where we see more progress day in day out,
Mm,
and that is because there's a huge amount of talent which this field
mm,
has been able to attract, and the who's who of these spaces, they come and contribute to this. The other side of the story is because it's blockchain, and blockchain is a unique proposition in that regard because you need not only from almost every facet of computer science, but you also need things like game theory and mechanism design and so on from
mm.
economics. And then there are others like law and psychology and things like that, which also all come in together to provide a very good product or an ecosystem. And that's why it's kind of the culmination of many different ideas coming from different paradigms, which make this so much more exciting and so much more fun to work with.
Yeah.
On the other side, because it's such hyped up and there is a lot of buzz and hype, that means that there will always be certain aspects where it will be inflated, and it
Mm,
will be a bit hard for end users to recognize what is the reality and which parts of it was the imagination. And there's a lot of promise, but with a lot of promise comes a lot of responsibility, and sometimes people get carried away on their imagination because this has so much of promise. And those are the kind of risks that I see, because unless we are able to safeguard users, we are able to
yeah.
safeguard our community from the bad actors who are not shying away from being intellectually dishonest, although they know the details,
Yeah.
then we pose a real threat, because this way it will all just be a scam which regulators try to stop and things like that. That's the
Yeah.
kind of mental image that most people have of this industry today, outside of
Yeah.
this outside of our community, and that we will not be able to shed that unless we change the ways in which we build it.
Yeah. Yeah. It's a very interesting space, isn't it? Like, in terms of, for example, if a retail user or investor gets burnt on a token, like because of market volatility, let's say, and it loses a lot of value, I think often what you see is them projecting this onto the quality of the project as well, and being like, okay, and then getting like very strong feelings against this project, which yeah, like it isn't really in the control of the project sometimes how volatile this new asset class is moving.
Yeah, and but on the other side, like, I don't know the stats, but let's say out of every 10 projects, eight of like 10 projects who suffered like this, eight of
Mm,
them might be legit, but two of them might be, design their crypto economics in a way which led to this downfall in a knowing
yeah,
manner, I would say. So those are the kind of risks, and that's why it's very hard to give a blanket judgment about any one of the projects, but the nuances almost get lost sometimes.
Yeah, yeah, I think you're right. That's a common thing. I think that nuances get lost in many ways in this market, even if it's technically or let's say psychologically or appearance of projects or whatever. Well, speaking of hype, as you mentioned it, obviously data availability is a hot topic at the moment. And there's competition as well. There's other projects working on this. There's, for example, Celestia and EigenDA, I guess, two names that get mentioned alongside Avail. Is there any sort of framework you can provide here in terms of like how does Avail compare to these competing solutions, and how do you differentiate yourself?
Yeah, absolutely. I think one of the things to understand is every solution has trade-offs, and the different products that you see in the space kind of try to target different positions in those trade-offs. For example, for Celestia, they use a hash-based mechanism, which is fraud-proof secured. As I was discussing in the beginning, like I was probably talking more in terms of executional correctness, but in data availability guarantees also similar roles play, which means that you can either get a fraud-proof secured DA layer or you can get a validity-proof secured DA layer. Celestia is a fraud-proof secured one, whereas Avail is a validity-proof secured one. Um, the, the other side to the story is that because of the layer twos which are building on top, which are all also execution focused, it is important that the executional guarantees also match with the DA guarantees. Because as a ZK rollup, you wouldn't want to have the validity proof of the execution, but wait for a challenge period for the DA layer fraud proof to either come in or not come in.
Because it's much slower. That's like you made a trade-off decision there to get that benefit, but then you lose it then again through another decision, is it?
Exactly, absolutely that. And that's why it is important to understand that all the stacks need to have a coherent security guarantees. Otherwise, it can be a bit of a mismatch. You will not be able to provide your users with the best in class that your product has to offer. On the other hand, I mean, then comes the familiar things about Cosmos SDK, which Celestia uses, versus the Polkadot SDK, which we use, and the nominated proof of stake, the validator set sizes, the hybrid ledger, and so on and so forth. These are familiar differences which arise due to the constructs that and the architectures that we have chosen. And for example, they provide instant finality, which is awesome unless there's a network partition, in which case there can be problems. Whereas on Avail, because it has both Babe and Grandpa, where Babe is the block production engine and Grandpa is the finality gadget, it can keep on producing blocks even if finality is stuck due to some network partition. And those are the kind of guarantees. And this is a classical dilemma of computer science, where you cannot have both the liveness and finality guarantees on the same ledger. So these are the kind of differences between Celestia and Avail. On the eigenlayer front, they choose a more of a data availability committee approach, but they use Ethereum, the asset class, as a restaking primitive on top to be able to give a good crypto economic security. But that comes with its own centralization vectors, and as I mentioned, that there are certain classes, there are certain problems where you want a sovereign chain of your own, like the one I was mentioning for Avail, when the discussion was around being a parachain or not. And we chose because we wanted to be a sovereign chain and not use an existing asset class, which the EigenDA is using to create a DAC on top of Ethereum.
Okay. So yeah, some technical differences generally, where you made your decision in terms of the trade-offs, and I mean, these other projects made theirs. and I'm sure you have your opinions on some of those decisions as you went a different way. You mentioned light clients, perhaps to keep talking about this technical infrastructure. And the light client part, you said you coded from scratch. So obviously this is something that you deemed important to incorporate and to include. Can you tell us why light clients are important here and how Avail uses them, and how you intend to make this sort of an adopted feature in terms of wallets that will incorporate it and things like that?
Yeah, I think because I think a bulk of your listeners come from the Polkadot world, so maybe this will be a bit easier to explain, but correct me if I'm wrong. So essentially, if you think of the light client proposition, like what does light clients do? The first of the foremost guarantees that the light clients need is the correctness of execution in an execution-focused blockchain. For example, on Ethereum, and Ethereum light clients want to know the account balance of a particular account. And for that, it can either ask an RPC provider to give the balance and trust it, which almost everyone does today.
Yeah.
Or it can ask not only the balance, but a proof that inside the state hash, this is the particular state that belonged to that hash, in order to provide a cryptographic proof that the account balance that was supplied is actually correct. I think in Polkadot, they take it like they have been trying to make a light client pretty for a very long time using the Substrate Connect project, if I'm not wrong. But even before that, there were other projects which were there. And for us, it's a bit different, but the guarantees are pretty similar. For example, in execution-focused chains, the actual execution is always done by the validator set. And hence, the 2x3 plus have to agree on the execution guarantees. Whereas in a DA-focused blockchain, data has a special quality in which it can be sampled, which means that even if the light clients only pick and choose a few bits of the entire data and know that they are actually available, they can infer a lot on the total availability guarantee of the entire data. And this is the superpower of data against that of execution. And that is why our light clients, they provide us a solid guarantee with very few amount of resources that the data behind the transaction execution is available. Right? And that is extremely important because not only you need the executional guarantees, you need the data guarantees, as we were discussing earlier. So the light clients, they form a decentralized peer-to-peer network on top. And we want to give them and all the people who run the light clients the guarantee that even if the 2x3 plus is dishonest, then also they would be able to either be able to catch that the data is not available, or once a data has been deemed to be available, they can rely on the peer-to-peer in order to reconstruct that data. That is the guarantee of the light clients that we want to provide.
Okay, let me see if I understood this correctly. So perhaps with light clients, right? Is that sort of is that from the user perspective then, like he has a locally run lightweight client which can confirm if certain data sampled on Avail is actually available or not?
Absolutely. But at the same time, these are going to be abstracted because they would be sitting inside the wallets. And those are the kind of efforts that we are already having with, let's say, someone like Subwallet, where we are already exploring ways in which we can keep the data sampling so abstracted that the user wouldn't have to even worry about running this client separately.
Right. But and at the same time, he gets better guarantees, so to say, with less trust assumptions that things are going correctly on the chain.
Absolutely. Because in order to know whether the executions were done correctly on an L2, you need two guarantees. You need execution guarantees, which come from the ZK proof or the fraud proof. And the second is the DA guarantee, which comes from the data availability sampling done inside the Avail Light clients.
Right. And you said even if something is off, I think you said if there's more than 2/3 who have manipulated something on Avail, even if something is off, the light clients would still be able to reconstruct the correct data?
So there are two things that I said. The first is even if the 2x3 tries to manipulate, you will be able to catch it. And the second is once a data has been deemed to be available by a large majority of the light clients, these data samples will reside on the peer-to-peer network, and that's why any new client will also get the similar guarantees. So think of it like a torrent network where once you have uploaded the file and enough people have downloaded even parts of it, then even if I cease to publish that file on the torrent system, you can still get enough, seeds out there in order for you to be able to download the entire data.
Okay, so the samples might even coexist on another peer-to-peer network of these light clients next to the on-chain on Avail.
Yes, absolutely. And that's why there is this overlay peer-to-peer network which we have been focusing on, which keeps these samples in a highly available manner. And that's the crux of data availability. You don't want to only rely on just another chain for this. You want to take it in your own hands where these clients keep them together by themselves.
Got you. So it's sort of like an added layer of security, making sure the data is available. And is there another layer of, well, no, I guess it's more secure that way, but then can the light clients be manipulated or tricked or something? Or?
Absolutely. There are open challenges in the peer-to-peer layer. Peer-to-peer layers have existed for a very long time, but security of peer-to-peer layers are still a work in progress, a research that is being done. It is very easy to manipulate a single light client, but the power comes in the numbers. So that's why, if you theoretically talk about it, then there needs to be a lot of anonymization of the light clients, a lot of handshaking and secure connection on the peer-to-peer layer, and so on and so forth. The discussions and the research around it is being done, but we have failed to see any radical solution there or a solution which has very good performances. But then also we keep on trying to provide the best security possible on the light client layer, but it still has to mature a bit.
Okay. All right. Super interesting. Thank you for kind of diving deep into that part as well. I wasn't aware of that at all. So perhaps if we look just forward now, what are sort of the next big milestones for Avail? Things that people interested in Avail can look forward to or anticipate, and or any upcoming features, partnerships. How are you? What's the state of adoption that you're seeing? Projects that are committing to using Avail or testing already and things like that?
Yeah, absolutely. So we have been building this solution for some time now. And right now we are running our incentivized testnet, which is the last leg of the testnet before we launch mainnet. Mainnet should be sometime like late this quarter or early next quarter. So people can look forward to that. But if someone wants to get participating today, the incentivized testnet is still running. The challenges are out there. It's called Clash of Nodes. And we are running it till now. There are some partner challenges where you can not only use Avail in isolation, but use it with some partner like, let's say, a Madara chain by the StarkNet guys, or you can use Dimension chain by the Dimension folks, and so on. There are other partner challenges which might be coming soon. And The entire set of challenges are also in the docs, so people can take a look at it and how to participate on them. Some of them, like, we want to cater to all classes of users. So starting from validators whose program has ended, and as I mentioned, there were, a few hundred validators which participated in that program. There are also, things like simple account transfer, account balance transfer challenges. Like if you can find a security vulnerability, if you can mount a governance attack. These are all the kind of challenges which are already running right now. We might be, giving out a light client challenge pretty soon, so people can look forward to that. Other than that, in terms of traction, we have been announcing partners pretty regularly, so people can keep track of that on Twitter, on our social media handles. We have been, even right now, I think before coming on this podcast, we have been getting around 1.5 thousand to 3.5K data submissions per block. And we have been seeing huge amounts of traction there through the partner challenges and through the Clash of Nodes program. There has been millions of users, hundreds of validators, thousands of full nodes running. We have had GBs worth of data submitted, sometimes even more than we wished for, which was a good test and stress test of our system. And yeah, so that's how our node is right now. We are basically stress testing the network, checking out the code base, figuring out the problems, fixing them so as to be as ready for the mainnet as possible.
Right. Oh, that's lovely to hear. Good to hear that there's such traction as well, and you can kind of stress test things. So just to understand this, will Avail be largely like abstracted away from users? Like, for example, if I'm on a layer 2 that uses an Ethereum layer 2 that uses Avail as data availability solution, I won't really have to do anything with Avail. And let's say you guys have a token or whatever, the use case of that token would also be mainly towards, let's say, for example, other chains that use you as a data availability.
Absolutely. We are primarily an infrastructure provider rather than a user-facing application. So the primary users of Avail will be the rollups. The rollup users will only interact with the rollup themselves. Having said that, there are also newer constructs which are coming up. So it's very hard to predict what the end state will be. Like there are sovereign rollup and based rollup constructs in which the users can pay their fees in Avail and can submit their transactions directly to Avail in order for the rollup to pick that up from the Avail itself. So there are a few different nuances which are coming up in the rollup space. But if we take a look at major rollup infrastructures right now and the architectures therein, then yes, the users will be directly interacting with the sequencers of the rollup, and the sequencers will submit the batches onto Avail using the Avail token.
So just in terms of sovereign rollups that you just mentioned, is that could that be like a sort of concept like on Polkadot with the relay chain or something, that like other chains are connected to Avail, and that's like sort of a base layer, or what could that look like?
That's one way to think about it. Like you can think of the rollups as the equivalent to parachains and Avail being the equivalent to the relay chain of that world. However, the roles are not exactly the same. For example, there is no collator of sorts. I mean, you can think of sequencers as the collator of the world and so on. But then quickly the analogy, dissects from reality, I would say. And that's why it's a good mental model to think about it that way, but it might not be exact.
Okay, gotcha. Sweet. I think we dove into a lot of topics there. I think I understand them better now for sure. So I hope viewers as well. Yeah, I just love to give you, first of all, thank you for coming on the show and really explaining things very succinctly and nicely for everyone to wrap their heads around. I wish you all the best with Avail. I think it's super interesting what you guys are doing. I'd like to give you just the floor. Is there anything else you'd like to share with listeners, viewers, and also point them somewhere maybe if they want to get involved more and things like that?
Yeah, absolutely. I think we largely talked about the DA problem today, which is the centerpiece around which we want to build the Avail ecosystem. There are other problems in this rollup ecosystem that we are building, which leads to UX fragmentation, which leads to security dropping off and things like that. And very soon we will let the world know of our plans around that. So stay tuned for more things rather than just a DA layer. And other than that, other than that, just follow us on Twitter, check out our docs, check out our website. It's availproject.org. You can find Avail Project on Twitter itself. And I'm Prabal Banerjee on Twitter. So if you have any questions, drop me a DM and let's keep chatting.
Perfect. We'll put those links in the show notes as well for anyone to check out. And so did I understand this correctly? Something around UX fragmentation is coming up. You're cooking up something.
Yeah, we are at least looking at the problem hard. Whether we are able to find a definitive solution or not, we'll see, but we will share it with the community soon.
Okay, lovely. We'll be on the lookout for that. Thank you, Prabal, for coming on the show anytime again.
Thanks a lot. Thank you.